Hello, welcome to my mathematics class. I'm continuing with my assignment problem. This is an assignment problem. Say I have already taken a class on assignment problems, and this was the problem that was explained in my last class, and this was a problem concerning the minimum time that may be taken for 5 jobs to be assigned to 5 missionaries, and the very same matrix I am using here, but with a different uh, that is viewing it from a different angle. You see that here I have written the problem. In this problem, you see that I have written something here, salesman. I have written here salesman. Salesman 1, salesman 2, salesman 3, salesman 4, salesman 5. And that there are 5 cities are there, and the profit the salesmen are likely to make if they are assigned the cities are given here. For example, you see that the salesman 1, if he is assigned the city A, he will be able to make a profit of 32,000 per month. Let us take it to be 32,000 per month. Let us take it in this way, 32,000 per month. And here you see that this salesman 2, if he is assigned the city A, he will be able to make 40,000 per month. So you see that likewise these salesmen are given, and the cities where they can, if they are posted as salesmen or assigned the cities, there the profit they are likely to make are given as a matrix. Now what is expected of us is to how cleverly or how wisely the salesmen be assigned the cities so that the overall profit is maximum. The overall profit is maximum. You see that this is also an assignment problem. This is an assignment problem. But normal assignment problem is a minimization problem. I have explained everything in my first class while doing assignment problem. I have explained everything, and there I have made it very clear that the assignment problem is always a minimization problem. But I told you while explaining things that there are chances that you may be asked to go for a maximization in assignments, in assignment problems. So I am taking up a problem where we are required to maximize a certain function. You see that here I have written very clearly that the profit. So if it is profit, you have to maximize. If it is expenditure, you have to minimize. So that is called your optimization. So you see that this is an optimization problem where the salesmen are given and the profits they are likely to make in various cities are also given. Now your job is to correctly assign the salesmen to the cities in such a way that the overall profit is maximum. So there are 2 ways of doing this problem. First one is first method. I will just give you the method. I will do by a method. One more method I will tell you. You just try, those who are viewing or the students who are interestingly watching this video, you try in the other way. I will do by one method, but I will explain both the methods. You see that the first method I will use, see the method 1. This is method 1. Here again I am using only Hungarian method. See what I do here is Normally what we do is, this is a maximization problem, so you have to convert it to a minimization problem. The method of converting it to a minimization problem is that multiply everything by minus sign. That means what? Minus 32, minus 38, minus 40. Like that, multiply every element in the matrix by minus. Now, the problem is now reduced to a minimization problem. Can you understand? After applying the Hungarian method, the method I have taught you in my last class, apply that Hungarian method and arrive at the assignments. And if you arrive at the assignments, you will get the what? The assignments, and you will get the overall profit will be given. But the profit will not be a positive one, it will be a negative one, because you have changed the problem to a negative one. So you will get that profit as minus negative. Now multiply that by again minus sign, you will get the profit. Can you understand? So you see that the method is multiply every element by minus. Now the problem will be reduced to a minimization problem. Follow the Hungarian method and go for the optimal assignments. After assigning, you will find that the assignments will give you overall profit which will be negative, because you are considering only a negative problem, that is minimization problem. You will get a negative value. Multiply that by again, because you have multiplied this by negative. But my problem, original problem is this. You are multiplying it minus and making it as a minimization problem. For the minimization problem, you are getting some negative figure. You want the solution for the original problem. This is your original problem. So multiply it by minus sign, you will get your answer. So this is the method I want my students who are listening this class should try that. But I will teach you the other method. So what I will do here is, I choose the maximum of all the elements here. See, which is the maximum of all elements? This is the maximum of all elements. Now I subtract every element throughout. I subtract every element from 41, so that it will be reduced to a minimization problem. I apply the minimization problem method and get the solution. So what I do here is that, so as I told you, you subtract from every element a constant from every element in a row or column. The optimal solution will not get altered at all. I have taught you that. Now let me start doing this. So your 41 is this, so this can be equal to this one. Subtract from 41 minus 32 is, it is 9, and it is 3, and it is 1, and it is 13, and it is 1. This is my first row. The next one is 1, that is 41 minus all the elements. So it is 1, it is 17, and it is 13, and it is 20, and it is 36, means 5. Then the next one is 41 minus 41 is 0. Then it is 14, it is 8, it is 11, it is 4. The next one is, it is 19, it is 3, it is 0, and it is 5 and 5. This is 12, and this is 8, 1, then 6, 2. So you see that, see 41 minus all elements. See, 41 minus everything will give you this. Okay. Now use the Hungarian method. See, what is that you will use? Use Hungarian method. See. So use Hungarian. This is Hungarian I write here. Use Hungarian method. So what I will do here is, now I will start explaining this. So choose the minimum of this and subtract from every element. So 1 is 8, 2, 0, 12, 0. Choose the minimum of this. It is 0, it is 16, it is 12, it is 19, it is 4. Here already there is one 0, so don't worry about this. 8, 11, 4. Here also one 0, don't worry about this. One 0 must be there in every row. Here there is no zeros, so take this one, subtract. It is 11, it is 7, 0, 5, 1. Check whether every column has a 0. If not, choose the minimum and start subtracting. You see that here you find that this row has zeros. So it is 0, 0, 19, 11. Second column has no zeros. So choose 2, subtract from every element. 1, this is 14, this is 12, this is 1, and this is 5. Here you have got 0, 12, 8, 0, 0. Here 5 is the minimum, so it is 7, it is 14, it is 6, 0, 0. Here you have got 0, 4, 4, 5, 1. Okay, now, so this is now after achieving at least one 0 in every column and row. Here you see that in every row and column has at least a 0. Here you see that here, what is that I have done here? Here 8, 0, 0, 19, 17. And here you see that I have made a mistake here. What is that? Here you take this 2 and subtract, you will get 0. 2, 0, 14, 12, 1, 5. And this column has a 0. Now, start assigning. As I told you, just go for the first row. You will find that there are 3 zeros. Don't assign. Come to the second row. You can assign. Simultaneously cut all zeros down below and also on this one. So this is. Now come to the third row. No zeros. Come to the fourth row. No zeros. So 2 zeros are there. Come to the fifth row. 2 zeros are there, so you cannot assign. Go column wise. First column you have got assigned and one is marked. Don't worry about that. Come to this, there is only 1 0. Assign this, simultaneously cut all zeros, and here come to this. So 2 zeros are here, 2 zeros are here, and there is, you don't have any, only marked this thing here. Now repeat this. Come to again row assignment. You go. This row you have got here 1 assigned, 2 marked, 1 assigned, no. Here 1 marked, no zeros. Here there are 2 zeros and here also 2 zeros. So you cannot assign. So go column wise. So you see that here we get into problem here. So if you come across problems of this type, you just go to the, it's a method. You just go to 4 zeros here, it referred to 4 zeros here refer to this, of which is the minimum here you have got. So this is the matrix that you must take, not this. Take the, because we are considering only a minimization problem. Now this becomes a minimization problem. Now you just 4 zeros are here, of which is the minimum here? 0. Therefore you can assign this. Can you understand how I solve this? See this what do you call as this hurdle we are able to overcome here. Say I do not know whether to assign this or this, this or this. So I go to these 4 figures in the initial matrix. This is my initial matrix. Don't take this because this is my maximization. Now this is for minimization. This matrix is for minimization. Come to this. What is here? 0, 5, 1, 6. Of all these 4, 0 is the minimum. So you just assign this. When you assign this, mark this and mark this and come to this, you will find that this is marked. Now you see, now you must find that all these zeros are either marked or assigned. Check whether all the zeros that have come are either assigned or marked. Now you see that here the first you find that this is assigned, no zeros. Second is also assigned. Third row assigned. Fourth row assigned and marked, and assigned and marked. So it is complete. Can you understand? Now you see whether the optimal solution has been got. Optimal solution means what? One salesman, one city. Now you see that here salesman 1 is given B, salesman 2 is given, sorry, this one salesman A is 1 is given the city B, salesman 2 is given the city A, salesman 3 is not given any city. Whereas 4 and 5 are given. Third salesman has not been assigned any city, and therefore it is not an optimal solution. Now you have to go for the method I have taught you. I'll start doing this using that method I have taught you in my last class. Okay, now you have to choose, you have to tick those rows which does not have an assignment. I'll repeat this. You have to tick when you don't get the optimal solution. Optimal solution in the sense every salesman here should have been assigned a city, but we find that the third salesman is not given a city for sales. So now he has to be given for which, so we say that the optimal solution is not obtained. Now what I say is the method of getting it is as follows. Tick, I will repeat because I am not writing, I am just repeating again and again so that it will reach you and it will help you to do the problem. See, tick the row or the rows which do not have an assignment. Now come to this. This is there is an assignment. There is an assignment. Here there is no assignment. So you tick it. And you go know that there need not be only one like this. There can be more than one rows, more than one rows which may not have an assignment. So in which case those rows which do not have an assignment must be ticked. So it is not necessary that there should be only one row without an assignment. Okay. Now, so you see that here it so happens that the third row is not having an assignment. So tick that row. So I have ticked this row. I have ticked it. And go over that row and tick the column which has a marked 0. Here that means what? Go over this row, stop at the marked 0 and tick that column. Here there is only one, so you travel over this. You see that there is the first column is having a marked 0, so tick this. So tick this. Here again I am telling you that not necessary that there should be only one column which has a marked 0. Here it could have been here also. There can be more than one column in which there can be marked zeros, in which case you have to tick the columns which do not have which have marked zeros. So you have to tick the columns which have marked zeros. So you see that it so happens that here in this problem the first column is the only column where there is a marked 0, so I tick it. So I have done. Then go over that column and tick the row which has an assignment. So go over this, come to this, tick this. Here again, so you see that it'll happen that there cannot be more than one assignment. Try to understand, in any row or column there can be only one assignment. So you see that in this column there cannot be more than one assignment. So there will be only one, so you will tick it. But while you tick the columns, there can be more than one column having marked zeros. Can you understand? So I'll repeat this. In this particular problem, third row is not having an assignment, so tick it. And go along that row and tick the column which has a marked 0. I repeat again, there need not be only one row which does not have a assignment, can be more than that. And when you move over the row to tick the column which has a marked 0, there need not be one column, it can be more than one column which has a marked 0, in which case those columns should also be ticked. Can you understand? So you see that this is what I do, and while you go over the column to tick the row which has a marked 0, which has a assignment, there can be only one, because every column, every row, there can be only one assignment, cannot have more than one assignment. Take it from me. Okay, now because it is the condition that one job, one machinery, one job, 1 to 1. Can you understand? So because of this I am tick. Then after then draw thin lines over the unticked rows and ticked columns. So you see that thin lines like this, thin lines but visible, so, like this. I am drawing like this, and this one. See that you don't go over one, so that if the line moves over one, you will have your confusion whether there is a number or not, like that. So when you do draw the thin lines, be careful to see that it does not in any way confuse you the numbers. They obliterate, in the sense you should not go over one, so that you will not be able to understand what number you have written there. So such confusions are likely to come. Better you see that you draw thin lines, so that what, nothing gets disturbed in the line numbers. You are able to read the numbers clearly. Can you understand? You see that I am able to read. This is 19, 0, 8, like that. Even if it is 1, see here there is 1, but I have drawn a thin line so that I don't get doubt on that. Okay, so you must be careful with that. Now after drawing this, count the number of lines. 1, 2, 3, 4. How many assignments are there? 4 assignments. So the number of lines tell you the number of assignments for the present. Can you understand? For the present, number of assignments are 4. So as a 4 lines are there. Then choose the minimum of all the open numbers. What is that? Choose the minimum of all the open numbers. 4 is the minimum. 4 is the minimum of all the open numbers. Subtract this 4 from all the open numbers, okay, and then add with the numbers at the intersection of the lines. I repeat this. After choosing the minimum of all the open numbers, subtract it from all other open numbers, add with the number at the intersection of the lines, and rest of the numbers don't disturb, keep it as it is. Now coming to this, here you see that 4. Now this 8 is at the intersection, so what is that you'll have? So this will be equal to 8 is at the intersection, so 8 plus 4 is 12. Then next, all other numbers don't disturb, because they are not open or they are not at the intersection. So 0, then next is 0, 2, 0. Here you see that this is 7. We have to be very careful. It is 7, 0. It is 7, 0. Then come to the next one. It is 0. 14 minus 4 is 10. Then this is 8. This is 10. And the next is 0. Come to the next one. It is 0. It is 8. It is 4. It is 2, 0. I am subtracting 4 from open numbers and adding with the number at the intersection of the lines. So here 19 plus 4 is 23. Then don't disturb the other numbers. So you will have it as what? 1, 0, 0, 5. Come to the next. This is also at the intersection. So for 15, it is 5, 0, 0, 1. So this is. So what is that I have done here? I have drawn thin lines on the unticked rows and ticked columns, chosen the minimum of the open numbers, subtracted from all other open numbers, and added with the number at the intersection of the what? The vertical and horizontal lines. Thereby I am able to give this. Now go for assignments, row wise assignments, then column wise, row wise, column wise. Repeat this again and again unless and until you get either the zeros are assigned or they are marked. Are you able to understand? Here again, this process must be continued. That is, choosing the rows, then columns, then this, unless and until it does not extend. That is, it stops at a place. Okay. Now, so you see that this is what we are getting here. So here, now you start assigning. Here there are 3 zeros, don't do. Here there are there are 2 zeros, don't do. Here also 2 zeros, here also 2 zeros, here don't do. Now come to this column, there are 2 zeros are here. Come to this, it is only 1 0. So you say that you do this, cut this, cut this. Then come to the next column, here got 2 zeros. Come to the next column, 2 zeros. Come to this, 0. So you see that here again there are 2 zeros. Column wise over. Row wise again a problem. Here 1 0, here 1 0, here 1 0, here 1 0. So likewise you are getting it. So when you get like this, it is better that you go for your minimization. This is your minimization problem. Here there are 2 zeros are here. You can very well choose, this was the minimum of these two. So choose this. So you choose this so that this will go off and this will go off. So you see that, so the first row is over. Second row, if you come, so this one means you will come to the second one is this. And third one, you know how I break this? Because when you have this and this, or yes, when you have these two, between these two, this is 0 and 1. So what I do is I choose this 0 because here it is the minimum. Because of that, I assign this. This is marked. And when this is marked, this is assigned, mark this because you have to mark the zeros. So you have done this. Come to this place. Again, you see that there are 2 zeros, there are 2 zeros. Column wise go. Here you see that 2 zeros and 2 zeros. But as we have done earlier in the last matrix, you just assigned here, mark this, and so what will happen here? So you will go for this and you will get this assigned. So you see that what is that you get? First row there is an assignment, second row there is an assignment, third row there is an assignment, fourth row there is an assignment, fifth row there is an assignment. That means my assignment problem is optimal. I have got the optimal solution. Now you see this is 1, 2, 3, 4, 5. These are salesmen, and here this is city, A city, B city, D city, E city. Now what is that assignment? Can you see this? What is the assignment here? X1 2. What is the assignment here? X2 5. What is the assignment here? X. So what is that you are having? So your assignments are X1 2. So x1 2 is assigned. When x1 2 is assigned, what is your x1 2 element? You have to go. Don't go to this minimum problem because you are completing the problem with minimization technique. But while you go for this x1 2, you should not do this. This is your element. But corresponding to this element, your corresponding figure in the original problem must be taken. Can you understand? See here, this is an assignment. This assignment refers to this 3. x1 2 refers to 3. That means x1 2 is equal to 1. Try to understand that x1 2 is equal to 1 means it is assigned. That means here I'll write here. See, it is a salesman, then city, profit in rupees, in thousands, rupees in thousands. It per month I have written here, so I'll write it as well. Now, first salesman, he is given the city B. What is that? First salesman is given the city B, which is nothing but your x1 2. So when he is posted there, he will make a profit of 38. Then second salesman, he is given the city E. What is that E? 2, 5. This is the assigned. That means what? x1, 2 is equal to 1. x2, 5 is equal to 1. That means assigned. Is equal to 1 means assigned. So what is the profit that he makes? 36. So this is 36. Then number 3. He is assigned what? A. That is x31. What is that? 41. So it is 41. Then 4. 4 is assigned what? He is given C. What is that? 4, 3. He is assigned. So what is the profit here? 4, 3 is 41. And 5th is given what? He is given D. That is x 5, 4. So you see that this is equal to what? 35. Now you add. How much will you get? So here. So 191. That means what? This is nothing but what? 191 followed by 3 zeros. So this is the maximum profit that the salesman would make if they are assigned the cities like this. So this is your maximization problem. This is your method 1. If you are using the method 2, I'll just hint, already I have taught you. Take the first row. What is the maximum here? 40. No, you just multiply throughout by minus sign. So what is that you will do? Multiply throughout by minus sign. So minus 32, minus 38, minus 40. Like that everything will be minus. Choose the minimum of this. For example, minus 32, minus 38, minus 40, minus 28, minus 40. Among all the numbers, minus 40 will be the minimum. So subtract from 32. It will be like this. 32 minus, see, it will be minus 32. Minus 32. Take away this minus 40. It will be like this. See, throughout multiply by minus sign, it will be minus 32. Choose the minimum of all this, minus 40. Take away from that, so you will get what? 8. So this is your 8. Actually speaking, you will get here 8. So you see that, like that, you will form another matrix. So you see that you will get the matrix like this. That is a minimum problem. Now you use the very same method as I have done. See, this is what I have done here. Like this you go, then you come to this. You will get into problems like this because it won't be optimal. Use the method I have taught you there and come to this and go for assignments. After getting the assignments, the same, almost the same assignments you may get. So the same assignments, for the same assignments, if it will become B means what? You will go to B as what? This 38, and don't go to that negative figure because that is for minimization. And what happens is, or if you take this, without this, if you go for minimization, minus 32 you can take. So it will be a minimization problem, in which case here it will be minus 38, minus 36, minus 41, minus 41, minus 35. It is minus 191. But you multiply the original problem with minus. So you have to multiply this also by minus. So minus into minus 191 will be equal to 191,000. That will be, so almost you will get the very same. So this is all about your maximization problem in the assignments. Okay. So this is what we do. Now I will teach you one more on this, the assignments, because assignment problem is playing a very important role in the case of a traveling salesman. In the sense, the companies will have their salesmen, and the salesman is expected to visit cities for canvassing their product. So well, they go for example, you may have this medical representative or other representatives who are canvassing for their products in cities. So while they go, the company will pay them, bear all the expenses, but the company will see to it that the expenses on account of the salesman is low, but the profit they bring is very huge. See, this is the mentality of the companies. So what they will advise their salesman is that go by the shortest route possible. Suppose they are going from one place to another, say from Chennai to Pondicherry, means he should not go from here to Bangalore, then Bangalore to Pondicherry. They will not allow. He must go by the shortest route to this thing, Pondicherry, and that he is expected to visit a place not more than once. He should go to the place, finish off his job, and then pass on to the next city. He should not come back. He is not allowed to come back to the city where he has done, except the place where his headquarters is. So if he is having the headquarters at Chennai, he can come back to this. But while he goes on visit to other cities, he is expected to go by the shortest route and visit every city not more than once. That is called route condition. Can you understand? The route condition is that a salesman is expected to go take the shortest route from one place to another, and that he is not allowed to visit a place more than once, and that he can visit a place more than once. That is the only place, his headquarters. Can you understand? And this is, and you see that here it is again an assignment problem, because he has to assign the cities of his visit in such a way that he is taking the shortest distance. That means his overall distance covered by him must be the minimum, because the company will see to it that only when he visits, when he goes by the shortest route, the expenditure to the company will be minimum. So this is the idea behind traveling salesman problem. Okay.